Hey guys, welcome to another one-dimensional kinematics question. This time, the first example of a few for deceleration. Okay, so a car slows down from 22 meters per second to rest in a distance of 82 meters. What was its acceleration assumed constant? Okay, so for the most part, we're always going to be dealing with constant acceleration. Once acceleration starts changing, then we're going to need functions to represent different things. Okay, but for this, it's going to be pretty straightforward, constant acceleration. Okay, so let's write down what we know. Okay, so we're given the first speed and the final speed. Now remember, the final speed isn't given to you in a number, but you're told it's going to rest. Okay, so that means the final speed is 0, which means v naught, the initial speed, is 22 meters per second. The final speed v is 0 meters per second. Okay, this is through a distance of 82 meters, so delta d equals 82 meters. Okay, what was its acceleration assumed constant? Okay, draw a picture. So again, my pictures are really simple, no more complicated than they need to be. So I'm going to take these variables and I'm going to label them on the picture according to where they should be. Okay, so v naught is my initial speed. It's for a car. If you want, you can attempt to draw a car. It doesn't really matter. Okay, you've got your final speed v, you've got your change in distance, and you're looking for the acceleration. Now, a lot of the times you're probably used to hearing the word decelerate. Okay, so a car is decelerating, which in common context is used to imply it's slowing down. Okay, so for the most part, yeah, deceleration means slowing down, but it has a more important meaning in physics. Don't equate deceleration necessarily with slowing down. Equate it with, well, opposite direction of the velocity or the speed. Okay, so if the car's going at 22 meters per second, it has a positive speed, then if it's decelerating, that means acceleration should come out to be negative. So that's a way to check your answer. Okay, so now we're left with these four variables. Now the equation you want to use to connect these four is the following. Okay, it's v squared equals, so final speed squared equals initial speed squared plus 2 times acceleration times the change in position. Okay, so we are looking for acceleration, so I'm going to rearrange this equation for acceleration. The first step is to subtract v naught squared from both sides. Okay, so minus v naught squared minus v naught squared. You're adding to both sides. Okay, so that cancels out the v naught squared. Okay, so then you're left with v squared minus v naught squared equals 2a delta d. Now the a is being multiplied by 2 in delta d, so we want to divide both sides by 2 delta d. Okay, thereby canceling it out on this side. So you're left with, and I'm going to rewrite it so a is on the left, a equals final speed squared minus initial speed squared over 2 times the change in position. Okay, so the final speed is given to us as 0. So 0 meters per second squared is 0 squared minus 22 meters per second. Put that in brackets. That entire thing gets squared divided by 2 times 82 meters. Okay, so when you go ahead and calculate that all out, you should get minus 3.0 meters per second squared. Okay, if you check back to the original problem, okay, we had 2 sig figs here for the 82, and the 22 also has 2 sig figs. Therefore, our final answer must also have 2 sig figs, which it does, minus 3.0. And so you have the acceleration assumed constant. Okay, so that's it for this video, guys. If you enjoyed it, be sure to hit that like button. Just share it with your friends if you feel that they could benefit from it as well. And subscribe to my channel so you can be tuned in for new videos that come up. All right, thanks, guys, and have a good day.